I want to discuss Apple's new unified logging utilities. I will warn you, this is extremely boring information. So there's still time to go next door. Greg is a great speaker. I kind of wish I was there myself. And we're going to look at some of the reasons for this change that Apple did and go over some of the tools that we use to interact with the new unified logging. We'll include a short look at the console app and a bit of a longer look at the log command line tool that Apple released with macOS Sierra. So we're all used to the way that logs worked in OS X in the old days. Typically, they would be stored in a location like var/log, or perhaps in a library folder or user library folder. And Apple has supported a variety of logging systems. They've supported the Unix syslog logs, their own ASL Apple System Logger format that you can use their built-in APIs for, like NSLog or Logger. They also support the BSM audit log tool. And while Apple still supports these legacy logging systems, for now, we don't know what the future holds for those. They've written this new unified logging system to which all of those legacy APIs forward their data now. And this new system supersedes those legacy systems. So at some point in the future, we shouldn't be surprised to see some of those older ways going away. As of macOS Sierra, Apple has completely revamped their logging system with this new unified logging. This is from the syslog man page, which explicitly calls out to look into this new logging system. The events generated by those legacy APIs, like I mentioned, things like NSLog or the ASL log message or syslog or logger, all of that is being redirected to this new unified logging system. And these changes mean that the tools that we use to interact with the logs or to create them or collect them or analyze them have changed as well. So why would Apple do this? Besides the fact that they enjoy making our lives way more difficult. Unified logging does offer some distinct advantages. For one thing, it's using a new single efficient performant API across all systems and across the macOS system, rather than having a scattering of different ways to do logging using the system tools. They announced this in 2016 at WWDC, and to quote the engineer on stage, who said, "What we wanted to do was build one common efficient logging mechanism across the whole system that could be used in both user mode and kernel mode." So their stated goal, is they want to maximize the amount of information that we can collect while minimizing what they call the observer effect, which is something that happens when you add logging to a process, and just by virtue of adding that in the process, you're changing the timing of the operation, and what you're looking for might go away or move. You can think of it as kind of Heisenberg's logging. And this unified logging also aligns with Apple's slow march to unify their operating systems. So this system, unified logging, is consistent across macOS, iOS, tvOS, and the watch as well. So this desire to make a more efficient logging system does make a lot of sense. For instance, we as humans always are struggling with this balance between minimalism and too much information. And historically, computers have also played this out on a bit of a grand scale with their primitive origins up till now with this crazy, vast network that we're all walking around with in our pockets. To help illustrate a little bit of this, dynamic range in information gathering, I thought we could look at a different field of study from which we can derive some insight, and that is literature. Ernest Hemingway is one of my favorite authors. He had a way of boiling down a sentence to its barest form. He called this his iceberg theory, or the theory of omission. He believed that his work should derive implicit meaning rather than needing to spell out or lay down the surface value of all of the themes that he's trying to get across. There's a contest known as the Hemingway Challenge, which is to see if you can write an entire novel in 6 words. And it's based on a line of Hemingway's which reads, "For sale, baby shoes never worn." And this is seen as kind of the canonical example of the Hemingway style. And as a quick aside, I was convinced to enter a Hemingway challenge once, and I managed to win tickets to the Bumbershoot Festival in Seattle. And I can only imagine that that was a pretty low bar year for them. But for me, this is clearly the greatest achievement of my life. At the other end of the spectrum, we have the vast vocabulary of the Irish novelist James Joyce. This is a man who never met a sentence fragment that he did not want to compound or an aspect of consciousness that he did not want to stream. Reading Joyce sometimes feels like you're reading an encyclopedia if it was written by a poet. So these 2 silly examples just show kind of the dynamic range between how humans can consume as little or as much information and deliver it and understand it. Bringing this metaphor back to logging, up until Sierra, Apple was using the legacy ASL or syslog style of logging, which meant essentially writing out to files. Those files may be compressed at a future date, but it was still writing files to disk, to basically text files. So to preserve resources, disk space, et cetera, this meant that developers tended towards that minimalist end of the spectrum with the information that they wanted to capture. However, with unified logging, Apple is encouraging developers to indulge their inner Shakespeare a little bit because of this database-backed binary log format that they're using now. It's highly efficient and performant on disk. In Apple's own words, less is no longer more. They explicitly tell developers to be as verbose as possible in their logging. The more logging that is available, the better we'll be able to troubleshoot our processes. Having more logging makes it easier to find patterns and to isolate events that you can then take back to the originating code to try and figure out what is going on. And also allows you to follow the flow of the process a little bit better. So to recap, unified logging allows us to be efficient in capturing and storing log messages to disk and in memory, manage the logging behavior and persistence of the events, capture messages across all levels of the system, and allows for the use of custom configuration profiles for configuring logging as well. The log levels in the system are similar to the way they've always been. These correspond to the different types of messages that your app or script may need to capture. Only messages above a defined level are configured to be persistently kept on disk. But you can change that configuration and kind of mold it to retain the information that you desire to retain for your own process. The log levels can be overridden also with configuration profiles, which is pretty handy now. The default level captures information about things that might result in a failure. This information is initially just stored in a memory buffer. As that buffer fills, these messages are compressed and saved out to the data store. And then they will remain in that data store until a quota is exceeded, at which point the messages are then purged. Info log level is also initially stored in the memory buffers, but except for anything that's a fault or an error, this level of logging does not save out to disk as the memory buffers fill. And this is for capturing information that may be helpful but isn't necessarily essential for troubleshooting any errors. The debug log level is intended for use by developers in debugging their own applications, but is useful to us as sysadmins as well when we are trying to troubleshoot an application or a script or one of our own processes. And this contains information that might be useful during development or troubleshooting, but also in the use of an application. And these events are only captured in memory when the debug logging configuration is enabled, either through the command line or with a configuration profile. And these messages are also purged from disk in accordance with the persistence setting that you have. The error log level, these are always saved to the data store. These are a little bit more interesting types of messages that you might want to keep. But again, when that storage quota is reached, they also begin to be purged. These are intended for reporting process level events, and logging at this level captures the entire process, information about the entire process. And fault level is the next step up, and these are also always stored in the data store and then again purged as the quota is reached. And these are intended for system-wide or multi-process errors. So logging at this level will capture an entire process chain, for instance. Logs are now stored in a compressed binary format, and they're located under the var.db directory. There's two subdirectories there. The diagnostics directory will store the file paths of the logs themselves, and they're named with a timestamp, so they're easy enough to figure out what happened when. In the UUID text directory will contain some references and other data that is referenced by the logs themselves. All of the legacy APIs, as I mentioned, are now redirected to this new unified logging system. So if you build your app using the 10.12 or above SDKs, by default, it will use the new unified logging. You may continue to build by targeting 10.11 or earlier and continue to use those older syslog style systems as well. The new APIs that replace the old ones have descriptive names: oslog, info, debug, fault, oslog create. Some of these sound familiar because they kind of correspond with some of those log levels that we discussed earlier. And again, these APIs are available for when you target your app against the 10.12 SDK. By default, the log format contains some built-in metadata. And I realize this is hard to read, but I left it in there on purpose because I wanted to see if anybody in the back could actually read it. But we'll make it easier for you here. That's better. Like I said, the format includes certain data about the event, including a timestamp in a standardized format. And this allows you to customize your search commands against a specific time. So if you say you have your Macs are all dropping network at the same time every day, you could use the timestamp of that log event to then pull the events before and after for a certain period of time and try to figure out what's going on. Next, it shows the thread, log type, and activity. And The thread and activity are just computery stuff that nobody here cares about, except maybe Papine. But the log type corresponds with those log levels that we discussed earlier, so things like info or debug or error or fault. The PID and process in library describe which process is throwing this event, and in some cases may include the system library that the process is calling as well, so you can more granularly figure out what exactly is causing this log event. Next, it shows the subsystem, and these are categories, if you will, that you can call against to only show the relevant log events for a specific subsystem. So something like com.apple.timemachine, or maybe Spotlight or something. And this will come up again later, but I just want to mention here that the subsystem also has a category, which is almost like a subsystem of the subsystem. So you can have multiple categories per subsystem. So you could essentially maybe tag a specific type of event within a subsystem itself. And similarly to the timestamp, this allows you to be more efficient with your log collecting if you're looking at a specific subsystem rather than looking at the entire OS system. And finally, the message itself. This is what the code is sending to the log event. When you are creating your own logs, you're going to want this information to be as relevant and searchable as possible, so that when you're evaluating these logs later, it makes it easier to go back into your code and figure out where exactly you went wrong. So we've covered what unified logging is, why Apple is moving in this direction, ways that Apple is encouraging the developers to be more verbose in their logging, and how unified logging stores and discards logs. But now that we have all this noise, how do we isolate the signal that we need? To help us process all this verbosity, Apple has given us a new command line tool as of macOS Sierra called log. And this binary can be used to capture or stream or show logs in real time. Or you can pluck logs from some point in history and save out for later analysis. There are many options available. And Apple has pretty good documentation on this. The man page is actually kind of useful. And for the purposes of this talk, we're going to focus on the subcommands that come with the logging or the log command line tool. And these are collect, config, erase, show, and stream. The show command allows us to query the logs for specific items in Apple's terminology predicates. You can kind of think of that as categories or types of information that you're looking for. And log show is kind of analogous to running cat or less or grep against a log file in the old days, where you're searching for a specific event in that database of logs. You would use show to parse the records directly from those logs that are saved in the binary format in that specific directory, or you can pass a log archive file that you've created to log show, and it will display the results of that log archive as well. And we'll get into that a little bit later. One thing to keep in mind is this command requires admin or sudo access. So if you have standard users and you need them to pull logs for you, you might need to work around that with your management system by using Jam for Monkey or something to run this command on their behalf. You can customize the output and filter on different types of predicate filters or timeframes. The default behavior of the show command disregards any info or debug level messages, but you can, with another flag passed, you can include those info or debug messages as well. You can choose different outputs. The default is syslog, so the result will be something that you're probably familiar with. But you could also choose JSON as your output if your goal is to take that data and incorporate it into your own scripts or to save it for later processing. In this example, we're searching for the string shutdown as an event message. So this is, again, analogous to running grep against the system log in the old days. And we're displaying the info level logs as well, so we want to include those. So it'll be a little bit more information than what you would get normally. And we're limiting the output to just the last 12 hours of logging. So otherwise, you're just going to get, months or more worth of logs showing up, and you may not want that. And here we're using the debug log level, and we change the style to JSON, so it'll save out in JSON format. And we're looking at the past 7 days of information. So instead of 12 hours, but also because we don't want everything, we can just pull 1 week's worth of logs. And finally, here's an example of returning logs related to the Finder subsystem. And we want to specify the start and end time of what we're showing. So instead of just saying the last week, the last day, you can specify, I want logs from this second to this second. And it's in a standard UTC time format that you can pass to the log show command. So these predicates can get pretty complex. So to take a look at those real quick, the predicate-based filters are filters that allow you to sort the messages or return messages that meet the criteria that you're looking for. The filter argument will define a pattern, and it's using Apple's NS predicate rules that you can find on the developer site. The supported keys, here, this is the printout from if you just run the command without any arguments, and it gives you the help output. So going through these keys real quick, the event message matches the pattern of the message text. It's, again, like running grep or cat against a file. So you're returning a piece of the message, the log event text, or maybe an activity name of the log or trace event. And this selects text from the event, so you want to pass the string with double quotes there. The event type matches the type of event, clearly. Some of the types can be log event or trace event. There are a few others in the documentation. The message type here matches the type of message in log event or trace event that you're looking for. So again, these include things like default or info or debug. In this example, we're using info, message type equals info. You could say equals error if you wanted to return just those severe error messages. Process image path matches the pattern within the name of the process that originated the event. So in this example, they're using the ends with verb with D, so you're looking for some system daemons that are generating log events. Or you can pass a name of an application or a process itself. With the process ID filter, you can restrict the results of what returns to those of one or a set of processes. This selects the entire, the processes with the IDs matching the criteria that you pass. So in this example, they're showing any process with an ID of less than 100, so that it's just returning some low-level system processes and returning the log events from those, and nothing above. Sender image path matches the pattern within the name of the sender that originated the event. This could be a system library or a text or a framework or any valid binary that is generating the log event. And the subsystem, again, matches the pattern within the specified type. And these are written out in the same reverse DNS format that you're used to if you've dealt with preference domains or launchd. So for instance, if you wanted time machine, you would change that to com.apple.timemachine. And again, all of this stuff only works with the newer APIs that ship with macOS 10.12 and above. So you would want to target your AppleScript to those OSs to make use of this new subsystem category. And then when the category is used, which again is like a child of the subsystem, you can have as many categories as you want per subsystem, but the category does require a subsystem because it relies on that. That's a lot. You can see there are many options for viewing logs from storage or that reside in memory, but we don't just want to look at events that have already happened. We might want to ride along with the logs as they're being generated. So the log stream command is similar to show. And this one, whereas show was kind of analogous to running grep or less or cat, this one's more analogous to tail. If you've ever run tail-f against a log file and you can see the events happening in real time, that's the difference here. This will show events as they occur. And to continue the theme of the example, we're streaming info level log information from the Finder process here, and it's showing the output as JSON. So again, you can customize that to be a syslog style, regular log format, or JSON if you want to ingest that information. Here we're using the timeout flag of 1 hour. So this is useful if you don't want to sit there until a process is complete and then quit the stream. You also don't want it just to continue running while you're out having lunch. You can set the timeout. So say you're troubleshooting your provisioning process and you kick off the provisioning, you can run this log stream and just let it run for an hour while the provisioning is happening, and then it'll stop collecting logs at that point. And finally, the activity type can be changed as well, and the log level. So again, there are tons of options available to here. We can use this to view logs in real time, or I suppose you could redirect this to a file to be used later. If you want that information to be in, say, a plain text format. But Apple does have a method for collecting logs into a supported format that can later be used for analysis, and that's the log collect. And you pass it a path to the log archive file that you want to create, and the log archive is their proprietary format for viewing these log events. And collect is intended to just kind of dump out a chunk of logs from, say, a period of time that you can either then ship to someone else or save for later analysis. It's similar to how, if you've ever done the sysdiagnose key command, which is like you have to hold down like 11 keys, but you only have 10 fingers. And Apple always wants that with their radars. Some of that format is also in the log archive. Should point out that console app will see and open these log archive files, so you can use console to also view the results of one of these files that you create. In this example, we're passing the path to the log archive bundle that we want to create and defining a start time from which to begin collecting logs. In here, we're saving the archive to the temp directory, and we only are collecting logs from the last 24 hours. And that can become useful if, say, you want to run a process on your client machines that runs every day and collects the previous 24 hours at a specific time and saves that out to a file, which you can then back up and store in your own data store for later analysis. One thing to note here is this command does also require root access or admin level. So again, if you have standard users, you're going to want to figure out a way to run this command on their behalf. And finally, if the output is not explicitly declared, the default will just be in the current working directory, and the default name will be system_logs.logarchive. And you can also define a number of days or minutes or hours to return. And the size is, they call it an approximation. And it's a little unclear whether they mean that's a limit that you would reach and then to then stop, or if that's the target that you're going for. The documentation is a little hazy on that. The config command allows us to configure or reset or read out the settings of a logging system. This is targeted to developers who need to change the parameters in their debugging tools. The config command will act system-wide by default, or you can target a specific subsystem to change the configuration for that subsystem. And you can view, speaking of the subsystems, you can view those in system library preferences logging subsystems. There's a whole list of them in there of what ships by default. So if you look at that directory, you can kind of get an idea of the sort of subsystems that you can run against the log show or stream command to pull information about those specific processes. And again, this requires root access. Standard users won't be able to change the logging configuration on their system. But you can apply some of these settings with configuration profiles as well. If we just pass the status flag here, it'll just read out the current settings. And by default, again, it's system-wide. In this example, we're setting the configuration to show redacted or private information. And what this means is developers may have constant data that they're logging out, but they may also have dynamic variables. And the system by default will not log some of that stuff because it may contain personalized information, a name or a phone number or something. So you could run this to change that setting that you want to receive all of that dynamic variable information in the logging as well. And the reset flag will just set everything back to the default. And then here in the other example, we're just setting the default log level to debug system-wide. And again, those levels correspond with the log levels that we saw earlier, like info and default and debug. You can get more granular here by defining the configuration for a specific PID, and the persistence options here define how you want that data to be stored to disk and for how long. So those options are off or default, info, and debug. I mean, you can change that again against a specific subsystem or the entire system level. And finally, we can define the config for a subsystem and category. If you're using a category, then subsystem is assumed because category is a child of the subsystems. And the last argument to look at here is erase, which is pretty self-explanatory, and it actually works. I ran this a week ago, and now I can't find any logs from before that. This will delete the selected log data from the system. If no arguments are given, it'll delete everything from the data store as well as any in-flight information that's in memory, the volatile logs. And if you use the all flag, it will delete everything in the data store all in-memory logs and any fault or error logs that you have saved as well. The TTL flag stands for time to live, and that's that volatile log information that's resident in memory. And so this will only delete that information and not delete anything that's in the data store. This gentleman, Howard Oakley, has an app that he posted to his Electric Light website called Constellation. It's very handy if you want to kind of poke around and see what the options are available in the new unified logging system. You can enter the parameters of what you're looking for. There's a bunch of drop downs, and then it will compile and show you the log command that you could then copy and take into terminal and run, or you can just run it directly within the app itself, and it'll display the logs that you're looking for. And you'll notice the elephant in the room here is Console app. Apple completely rewrote Console for 10.12. I believe it's a Swift rewrite. And the reason that I haven't talked about much is it's kind of useless if you don't understand the underlying options and commands. The interface is not the most intuitive. You can, if you do a search for something, you can then go and click a drop down and choose a subsystem. Things are kind of backwards. It behaves similar to log stream, so you can't just open Console app anymore and look at yesterday's logs. It will only start displaying logs as the events are being generated since you open the app. So that means that if you're doing any troubleshooting, you're going to make sure that you open Console app first and then trigger the event that generates those logs, at which point you'll start to see them. Console app shows all the messages on disk and in memory, and you can configure a column for the volatile log setting that will tell you where those logs are resident. And so the reason I'm focusing more on the command line options is because if you understand those, which none of us do or ever will, then it makes using Console app a little bit easier to figure out. So you'd be better off doing maybe a log capture or collect to save out a log archive with the specific parameters that you're looking for, and then import that log archive file into Console app, which will then display the logs for you in a nice GUI manner. On the other hand, one thing that's nice about Console app is it works with connected devices. So if you plug in your iPhone or iPad or Apple TV or Apple Watch, those devices will show up in the sidebar, and you can view the logs from those devices as well. And it should be noted here too that some of the functionality in Console app also requires admin level access or root access. So again, if you have standard users, you're going to want to figure out ways to collect these logs on their behalf. Okay, this is a lot of dry information. I can see we're all struggling here. I have to be honest, I'm kind of boring myself. So I want to take a break and talk about something a little bit more fun. And in keeping with tradition, I want to talk about a local Pennsylvania legend, which is the Steagles, which I just learned about this week. In 1943, because so many men were off fighting the war, the Eagles and the Steelers couldn't field entire teams, so they combined together, and they were officially called the Phil Pitt Combine, which is a very Pennsylvania name, I would think, but the nickname Steagles kind of stuck, except for in Philly, where they were so obstinate that they just continued to call them the Philadelphia Eagles. Even though the two head coaches notoriously hated each other, neither of them wanted to be demoted, so they were named co-head coaches, and it's kind of the beginning of seeing your offensive and defensive coordinators, which is a football term, I'm told. All players on these teams continued to hold down day jobs, including one fellow in Pittsburgh who worked at Westinghouse Electric, and his work was contributing indirectly to the Manhattan Project. So I found that kind of interesting. And even though both teams were terrible, only the Steelers had ever had a winning season in the past. And even though they, to this day, hold the record for number of fumbles in a single football game, the Steagles managed to pull off a winning record that year. And then after that year was done, they split up, went back to their cities. In the meantime, there was another expansion team, which meant that there were 11 teams in the league, which made scheduling hard. So the league tried to get them to combine together in the next year, but they hated each other, so they said no. Yeah. And so the Steelers went off and combined with the Chicago Cardinals, and they thought they'd be clever and called themselves the Card Pit team. But the problem is they went winless the next year, and so the nickname Carpet applied to them because all the other teams walked all over them. Okay, back to the boring stuff. As sysadmins, we routinely write scripts or apps and want to use our own processes, and we want to do automation. And so we also want to create logging content that is relevant to our own work. And of course, we're all responsible sysadmins here, so we're all logging, right? With everything we do, lots of logging. Me too. So let's take a quick look at how generating logs has changed with unified logging. To quickly recap, Apple's stated goals are they want one common, efficient logging mechanism for user land and kernel mode. They want to maximize the amount of information that we collect while minimizing this observer effect, which is the phenomenon that enabling additional logging may change the behavior of the process that you're looking at. And we want to log as much as possible to be able to discern patterns and more easily figure out what's going on. And also, they have a desire to design data and user privacy directly into the logging system itself. Somebody doesn't like the Steagall story. Yeah. Logging helps you understand which parts of your process are being executed and which branches of the logic follow each other. So it's a useful way to look at the flow control of an application or script. And it's useful to add as many events to the code as you can so you can better understand the information later by looking for patterns in the logs. So you want your logging to be useful and easy to search. You might want to use some keywords or tags in your logs. And it's useful to print, while debugging, to print variables out or property values so that you can ensure that the information that's being generated matches what you would expect it to look like. Knowing the sequence in which calls are being made from functions and methods is helpful. So it's always good to put a log line at the beginning of a method that you're writing, or an if statement or something. And this allows you to view the logs as kind of a story, and you can follow the path of the data as it flows through your script. And when examining crash logs, a stack backtrace is invaluable in figuring out the chain of events that led to the event that you're looking for. Daniel Chilcote has a really good blog post on this subject, which he titled Log Littering, and he is pushing back a little bit on Apple's statement that developers should be logging as much as possible because it generates so much noise that it's hard to find that signal. And to help with this, he proposes a few simple rules in this blog post for creating logs. And the advice is geared towards developers, but I do think it's relevant to our work as well, because we are the consumers of those logs from the developers, as well as creating logs ourselves in the automations that we're doing. The first rule is to don't litter the logs. And the analogy he uses is, wouldn't it be great if all recyclable materials just disappeared after 48 hours? Because then you wouldn't have to worry about generating a bunch of recycled trash. But the problem there is then everybody would just be tossing everything out the window because it would just disappear after 48 hours. So you would have this piles of trash everywhere. So just because logging is cheap, it doesn't mean that there isn't a cost associated with that logging. Using the annotation tools that Apple provides is a great way to make it easier to filter the logs. Removing the events from, say, the default category in your log events and maybe putting them into a debug category or log level means that if you have a user that's looking in console app, they're not going to see as much useless information, and you can focus on the useful stuff that you want to show to them. Because capturing a sysdiagnose, again, can generate such a large amount of data, and Apple always wants you to upload a sysdiagnose archive when you submit a radar, sometimes uploading 500 megs of logs when you just have a simple issue that you're working with is a little too much. So he's calling on developers to be a little bit more responsible in generating these log events. And finally, he calls for a new system log level that is user specific or user in the user context or user interesting to a user. And he calls this user concerning issues. That's the word I'm looking for. And the idea there is you could filter a log level just for information that would be useful to a consumer of your app or script, rather than information that you would look at as the developer. But until that happens, we can do some things with filtering and annotation and to make our logs a little bit more relevant for the intended audience. In your scripts, remember that as of Sierra, all of these APIs are using the new unified logging. So things like logger or nslog are compiled to write out to this new unified logging data format. Logger still works. One annoying thing with it is that -t for the tag no longer creates the tag in the log event itself. So in the past, you could use that to then filter for everything with a specific tag in console app. Now you're going to want to add that specific string to the log message event itself to be able to do that filtering. And hopefully this is something that Apple will fix. You're going to want to be descriptive in your wording so you can find the log events later. And keep in mind that you can't just open console app and look at the log that you generated 5 minutes ago. You're going to want to open console app, run the event, or run the process that generates that log event, and then you'll see it show up. In this example, you can send a log event and then display it using the log show command, which again will just look in the data store or in memory and pull all the logs that match the criteria that you provide. So we're using the event message contains hello PSU, so we're looking for a string in the log database. And in this example, we're just going back 5 minutes because we don't want to sit here and wait for it to look for hello PSU from logs that were generated back in like March. Here's an example of using the nslog via the Objective-C Python bridge. And because nslog is compiled to use Apple's new unified logging, running this command in Python will forward that log to the new unified logging system. and then you can use the log show or stream command to view this event at a later time. Similar to that last example, you can query the logs, and it'll query logs in memory and in the data store for the specific event that you're looking for. So here we're passing event message contains hello PSU. We're looking in the info for info level logs, and then it returns that event that we just ran via that Python script. And remember, again, you're no longer just writing text to a file. You're using this new performant unified logging, and Apple's recommendation is to go ahead and let loose and log as much data as possible, especially when you're debugging or when you're developing something. But again, you want to be responsible for the consumers of your app or process as well in terms of what they're going to see when something goes wrong and they need to do some troubleshooting. And as a general rule, if you're debugging your app or script and you've added some logging, but you continue to have issues and you're not able to find out what's going on, then that means you don't have enough logging. So that's a lot of dry information. I want to look at some specific examples I've pulled from the community using the command line log tool. And references and links are all in the slides, so don't worry about writing this down. This is from a post by our very own Eric Gomez. And this is his infamous Untouchables blog post from late last year after the Touch Bar MacBook Pros came out. We were trying to figure out what was going on with these new Touch Bar Macs, because when you imaged it, if you blew out the entire disk, when you rebooted, you were getting this message that indicated that the machine needed to connect back to the internet to run some updates. And what was happening is it was blowing away the EFI partition, which contained information that's specific to the touch bar itself, the embedded OS, and it needed to download that and verify it and restore that back for the touch bar to work. So we were seeing a message here in the logs that indicated that that something was going on. So we were able to use the show command and filter on the embedded OS install service process to show just the logs that were being generated by that process itself. In using this, Eric was able to kind of reverse engineer what's going on and figure out where it was calling from, what it was downloading, and this resulted in some radars that were open. And now that we know all of this, we're probably looking at a dark future of signed installers for macOS. And I say we all blame Eric for that happening. This is from Groob in Slack, Victor. And it's a way to track down errors during DEP when running the mdm dep-nag command. So what you could do here is you could run this stream command in a terminal pane, open up another tab, and trigger the mdm dep-nag, which should display something that says your organization's going to take over your computer for you. This is a way to troubleshoot what's going on there, and the process image path there contains the phrase cloud config. This is from Emily Kozelik's blog. It's a way to show the previous shutdown cause logs from the last 24 hours. And she also includes a link to another site that has that lists out all of the shutdown codes and what they mean. So you can, in conjunction with this message or with this log collection, you can take the shutdown code, go to that other site, and figure out if it was an issue that you need to look into, or maybe it was just a user rebooting their computer. This is pulled from the from Apple's Enterprise Connect documentation. Enterprise Connect is a tool that you can get from Apple Professional Services, and it allows you to synchronize local accounts on your Mac with an Active Directory backend without having to bind your Macs. So it'll facilitate that password sync between the two. And if you enable debug logging using their documentation, in Sierra, this is how you would pull those logs for review. Whereas in the old days, we would just grep for the string EC debug in the system log itself. Now you want to run that predicate looking for the event message containing that phrase. And also in this case, we're limiting it to the last 10 minutes. So you can try to trigger a few connections with Enterprise Connect and then run this command for the last 10 minutes to pull just that relevant information. This is from the GitHub wiki for the open source project Imager. Imager is using NSLog for its logging, so all of those events, again, are being forwarded to the new unified logging system. If you're running 10.12 NetBoot environment, this is how you would view those Imager logs. Again, previously, we would just be looking inside the system log or maybe a specific log that the application is generating. But now we're just calling against this database backend. And this is a way to look at events containing the phrase boot time. With this information, you can determine when a machine booted up and then use that time to then maybe do another call with a start and end 10 minutes before, 10 minutes after, to try to figure out if there were any interesting log events that happened right around the time that a system booted. And similarly, you can use the system wake to view time-based log events around when a Mac wakes from sleep. And in this case, we're returning it as JSON. So again, you can, if you're incorporating this into one of your own scripts or projects, you can use the JSON data and pull it into a structured format and interact with it with your own tools. And remember, earlier we said that configuration profiles was an option for configuring logs. Apple does have some examples that you can download. A lot of it is iOS-based, but there are some macOS examples as well. And this example is part of the configuration profile that Apple provides for gathering logs for a managed client. So if you're having MDM issues, this is what they recommend that you install and then run the process that triggers the event that you're looking for, at which point you could run sysdiagnose to create that log archive to upload to Apple for analysis. And I would be remiss if I did not mention this resource by Mosen. He posts it to GitHub and he updates this very regularly. Every time there's a point update, he goes in and compares the configuration profile payloads against what was available before, updates the documentation. So it's really great to go in there and look and see what's available for each, in general, just for configuration profiles. But he also includes a section on the payloads that you can use for configuring the unified logging as well. So whether you're just interested in the drip, drip, drip of the logs that are happening in real time, or if you want to drink from the fire hose, Apple's new log tool has you covered. Thank you. And we have some time for Q&A. I am probably going to hurt somebody. Careful with that coffee. Yeah. I was a soccer player.
So for the log,
yeah.
So for the log config thing, if you specify something, does that persist through a reboot, and does it wait for a reset, or does it automatically go back to defaults after a reboot?
It's a good question. I would think it survives a reboot, but that would be worth testing. I didn't try that out. And I don't remember anything in the documentation indicating otherwise.
Excuse me, is there a way to, I guess, what would be the proper syntax for, let's say, getting the process ID It's like printing pages. I want to do print page 1 and then 12 to 20 and then 50 to 100. Is there a way to do that with the log, to do process IDs?
You would need to know the process ID that you're passing. So you would use, the process listing or activity monitor or PS to try to figure out what the process ID of the application that you're looking for.
Because I'm looking for, let's say, like I said, just a bunch of them, just a range of them. Let's say, like I said, 50 to 100, for instance.
Yeah, I believe in the process ID you could say process ID equals 50 and then lower than 100, and it would return processes in that range. But of course, processes can go up to 50,000 or whatever, and they're kind of all over the place. So I don't think log itself has a way of determining what the process is that you're looking for.
So what about the old school system log?
It's still there. It doesn't have as much in it. You can still write directly to that log with your own scripts. Some applications might even continue to be doing that. If you look at it, you will see some specific things, and it's kind of clear that they haven't switched over to the new way of doing things. And also, you can always just continue to write logs to your own files in var log. That's probably not going to go away.
Okay.
Anyone else? Way in the back.
No, I can't throw that card.
Or over here. It's the friendly way of doing the squawk box.
On a very basic, simple level, if you don't know what you're looking for, how do you know how to look for it? In the old way, in console, I could just, so a user would say, something happened around 9 o'clock. Look in there, seen it. Ah, I've never seen that before.
Yeah.
But how would I know to look for something I've never seen before?
That's a good question. It's, what's the sound of one hand clapping? It's hard, and you get so much returned if you just run stream itself with no filtering. It's completely useless. So you would have to kind of either know one of those filtering methods you would want to focus on, maybe the time that it happened or a specific process or a subsystem. But yeah, this new system is very frustrating in that way that you can't just casually look at the logs and that serendipity of seeing something and having that aha moment is much harder now, for sure.
And why I still have it, I might have missed, did you mention anything about wildcards?
No.
In any of your things, can you put a wildcard in, or do you have to be absolutely precise in what you're looking for?
If you're doing a search, like passing a regex or something, I'm not sure. I would hope that would be available, because
Okay.
you would do that with grep, right? Yeah. That's a good point. He's ready to throw.
So, is there any facility for tying together all the older style log formats and the newer unified logs? Or when you use the new log command, is that only looking at logs output by processes that are outputting using the new APIs?
I think maybe the only thing that the new log, say show or the console app would work with is if you did create a sysdiagnose in the past and it created that log archive file. I would imagine that that's compatible with the new system. But I don't think that you can't just point log show at the system log and have it read that. But you still have those tools available that you were using previously. But it does seem like it's a all or nothing switch in that sense.
So if you're looking at some older apps and some newer, you might have to look at both.
Right, and if I'm understanding it correctly, the app will behave differently on the different OSs too. So the logging on a 1010 system might be different than a 1012 system, even if you're using the same app. Okay, thank you.